All right, I did want to prove this identity that the cosine of s plus t is equal to the cosine of s cosine t minus sine s sine t. This is not a proof you're responsible for in this course or like on an assessment, but you should see it, and it's easy to understand. It's not so easy to come up with the setup. You know, somebody came up with a really good idea in order to prove it, obviously, but it's not that hard to follow. So I want you guys to be able to do it. If you don't care, shut off the video, skip it. But maybe you'll find it interesting. Okay, so the stroke of genius, in my opinion, is that they figured out a way. We have to figure out a way to get the sum of two angles in terms of the individual angles. So somebody kind of said, well, what if we call this angle t? If we call this angle t, then this point Q1 would be the cosine of t sine t. Definition of your trig functions, right? The angle is t, therefore the x, you got it. And then if we add angle s to that angle t, sorry, I got interrupted here. So then this would be angle s, and this would be angle t. So this angle here, this whole angle would be s plus t. So this point would have the coordinates cosine of s plus t, sine of s plus t. And then they kind of said, well, so now let's take this angle here, this negative s, and move it down there, I guess. So that means this point would be the cosine of negative s, sine of negative s. But we could change this. Our even-odd identities, you can also see why our even-odd identities work here. This is the same as the cosine of s. Cosine of a negative is the same as the cosine of s, even-odd identities. And then the sine of s, whatever, we don't need to talk about the proof of that. Those are your even-odd identities. And then this is the point 1, 0. So I just did this whole proof, and I called this point 0, 0. And I could not figure out why my proof didn't work. And I sat there working on it for like 15 minutes. So you guys aren't the only ones that make these stupid mistakes, right? Okay. So now what we need to do then is we need to come up with a relationship between these points so that I can get this in the same equation as this stuff. And if we have a central angle, this is s plus t, and this is the chord that it intercepts, and we have another angle here, this is t and s, so that's also s plus t. Since these angles are the same, these chord lengths are the same. So the way we're going to get our formula is the distance formula between these two sets of points, I guess. All right, so that's where we're going to get our formula. So let's write that down. So the distance formula, we got to remember what it is. Square root. So you go x minus x. So I'm going to do p1 p naught first. So that's cosine of s plus t minus 0 quantity squared plus y minus y sine of s plus t minus 0 quantity squared. That's this length p, p1 p naught, equals, now let's do the length of the line between these two q subpoints, whatever, square root, cosine t, oh my gosh, I put a 0 in there again. X minus x is, oh my gosh, is minus 1. That one's minus 0, that one's minus 1, oh my gosh. So x minus x, cosine t minus cosine s, quantity squared, plus sine t minus the opposite of sine s, so that would be minus the negative is plus sine s, quantity squared, square root all that. All right, so this is all we need. Now we're just going to work this, simplify it, and it should clean up into this nice, beautiful identity. Square both sides. Gets rid of the radicals. And we don't have to worry about extraneous solutions because these are both positive. Square this. Cosine squared s plus t minus 2 cosine s plus t plus 1. Plus, square this. That's just sine squared s plus t equals, square this, cosine squared t minus 2 cosine t cosine s plus cosine squared s plus, run out of room, square this one, sine squared t plus 2 sine t sine s plus sine squared s. It looks like it's a mess, but we're really getting close. All right, so first of all, remember, sine squared plus cosine squared is equal to 1. But you got to have the same angles. So do I see a sine squared and a cosine squared here? Are they the same angles? Yep. So that's a 1. Plus 1 minus 2 cosine s plus t. So I got a 1 here, I got another 1 there, and then I got that. Here, I have cosine squared t, sine squared t. Those combine to a 1, Pythagorean identity. I have a cosine squared s and a sine squared s, plus 1, Pythagorean identity. And then I got these two oddballs, minus 2 cosine t cosine s plus 2 sine t sine s. All right, well, this is 2 and this is 2, so let's subtract those out. I guess I don't know, I kind of want to just be done. We're like right there. Negative 2 cosine t cosine s plus 2 sine t sine s. So do you see how close we are? We got the cosine and cosine, cosine, sine, sine. Let's get rid of those 2's. Divide this by negative 2, divide this by negative 2, divide this by negative 2. So I get the cosine of s plus t. Let's just put these in the right order. I want s first, t second. So this is, these cancel, 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 cancel. I'm just going to change the order here. Cosine of s, cosine of t, minus, change the sign there, sine s, sine t. Boom. I proved it. All right, so we use a geometric setup, and then just some simple algebra, and a couple Pythagorean identities in there to prove this identity. Now that just proves this one, but with that one, we could get the proof for this one. All we got to do is say the cosine of s plus the opposite of t. You know, I'm not going to do all these, but I just want to kind of show you how you would do it, right? So we would use this identity, and then when we get our individual sines of negative t and cosines of negative t, we'd use our even odd identities, and you're going to see why when you change this to a negative, this goes to a positive, okay? And then what about the sign? Well, for the sign and the pluses and the minus, it's a little bit trickier. We actually can use our, I'm trying to think, I'm not sure I know exactly off the top of my head. I think we use the properties, like the cofunction properties, or properties about the relationship between the sign and, I shouldn't talk, I don't want to sound like an idiot, but these kind of follow as a consequence of this more major identity here. I'm sorry, I'm not able to explain exactly how or remember it exactly off the top of my head, but I guess trust me, you can do it. If you want to see me do it, or you want to see how to do it, you know, we can kind of talk about it and figure it out a bit. And then to get the tangents, once you have the sines and cosines, the tangents are simply, you know, the sine over the cosine. You know, if you put those two identities over top of each other and clean them up and simplify them, you can derive the tangent. So this is kind of the major theorem, and then the rest of these are kind of corollaries, you know, like obvious consequences of the more, you know, more impactful major hitting theorem here. Okay? All right. Very good.